My name is Vivek, and this is my final project for the course Deep Learning that I'm taking in Harvard University Extension School. My topic of the final project is case studies in social media. So I would quickly want to just give an overview of why I chose this topic. Uh, I work for an investment bank, and my initial thought process was to start work on a risk analysis model, which will predict the risks associated with the stocks, or a typical stock picking model, which I thought was pretty typical and related to my project as well, which I work. But I recently learned that my company might be doing some work with the natural language processing. So I thought this project might be a good opportunity for me to get ahead and before I even go ask for an opportunity. So this was a motivation to work on this project specifically, and then I had to start looking for the right data set. So Kaggle was very helpful in that, and I found a uh, good data which has the comments for all the New York Times articles from 2017 to 2018, and it has 6 months for each year actually. um, the it has two files for each month, which is the articles and the comments.csv file. My focus for this project is to focus on 1 month's comments for that month's articles. So if you look at the comment dataset, what it has is it has a particular comment, and whether a comment can be an editor's pick or not. So my problem statement for the project itself is, you pick a comment and the model should be able to predict whether uh, this comment can be an editor's pick or not. So I think that's a problem statement. And technology that I've used for the project is Python, Keras, Matplotlib was for the visualization charts, and the word cloud APIs for showing some of the word clouds that I found were really interesting. Looking at the dataset, you I have 250,000 records for the March 2018 um, month, and there are 34 columns, but the columns that are of our interest for this project is comment body and editor's selection column, which is a binary column with 0 and 1. And this is the screenshot of just a sample data. So you would see the comment body, and on the right, extreme right, you would see the editor selection column as well. So this shows the distribution of uh, how many comments are editor's pick versus non-editor's pick. So you would see that only 2% of the comments are actually editor's pick out of 250,000 records, which is pretty imbalanced for me to directly use this for the training. So I think I have done some preparation before actually using it for modeling that you would see it quickly. So these are some of the word clouds that I found were interesting, and I'll show you why. So these are the common words in non-editors picked comments. You would see mostly related to US, the Bitcoin mining, cryptocurrencies, and look at the comments that were editors picked actually. So these are all the comments that were editors picked in New York Times for March 2018. And from the first look of it, you would see that it's all Trump related. So if you want your comment to be editor's picked, you go and find an article which is obviously Trump related, and go and comment on those articles. So yeah, I mean, this was pretty interesting for me to find out that the New York Times editors were actually were picking the topics which was only Trump related. So yeah. Um, So coming back to preparing the data, I think there were two approaches that were to handle this imbalance that I had. Um, One was the downsampling on the and then upsampling. So downsampling is basically it was relatively easier for me to downsample rather than upsample, because in upsampling I would have to generate user comments for editors pick data, which I think at this level was pretty tough for me to do it. So I went ahead with downsampling, and I chose 3:1 ratio. And finally, the total number of records for training I had was 19,224, and I divided the data with 90 and 10 ratio for the training versus test. So preparing the data for the training, I used from GitHub. I was able to find a project which was the helper class basically, and to generate the embedding of the word itself. So finally, with those 19,000 records, this was one of the comments that I find that was there in one of my resample data, and this is the final embedding that I have got. There are a couple of methods in data helper that I have overridden, and you would see that in my detailed report. um, so this is the final embedding that I have got for this comment that you see. So having worked in the federal courts in various ways for 30 years now, that gets mapped to this embedding. And you would notice in below you would see zero zeros. So these are all paddings to make sure it's a fixed number of fixed size array. And let's focus on the model now. I have used Keras for building the model, and I've used what I'm doing is building a sequential model. And the first layer of my model is an embedding layer, as I had mentioned before itself. um, and the parameters that I'm passing is input dimension is nothing but your vocabulary that I've built out of the words that I have, and the output dimension is 100, which is telling that how dense you want your vectors to be. So that's 100 here in our case. Followed by a convolution layer. So I'm using a one dimension convolution layer because we are doing a text classification, sentence classification, and you would want your filters to focus on only one row, which is just one uh, which will be part of your sentence. The kernel size is 3, which is telling you how many words at a time you want to focus on, and the activation layer value in my case. And then I'm following it with the pooling to maximize on the weights. Before passing it to a dense layer, I'm flattening it, and the neurons for the dense layer I have is 250. I tried with 500. I was not very sure to where to um, uh, where to put a line on that, so I went with 250. And the, I also noticed, I mean, I did not have the dropout of 20%. And what was happening that when I ran it for like 3 4 times, I saw that model was overfitting, and I was always getting 100% accuracy. So I added a dropout of 20%, and then it started getting much practical results, which was about 88%. And the the optimizer that I'm using for the project for this model is Adam optimizer, and the loss function is binary cross entropy. So yeah, when I ran the model for the first time, I think with the ReLU activation itself, which was just without the dropout, I got after 3 to 4 epochs, it was always getting 200%. So yeah, added the dropout of 20%, and I got 88% of the results. You can see the screenshot here. So this the first one was with only the without the dropout, and this is with the dropout of 20%. Yeah, so the next steps for the model is to actually spend some more time on the model and try to try to optimize it as much as possible, because I still see there's lot to do here. So once I have that optimization, what I would want to do is span the model to the whole data set, which is for the for 6 months of 2017 and 6 months of 2018, and see how the model behaves, and then try it by article. So basically domain by domain, I would say, where go to for every sector, how and try to model it for every sector. So it's an energy sector, uh, how that respects comment behave. So I think that's what I'm trying to get to for the next couple of months, time permitting. And also, I would want to use the trained embeddings word to vec and glove before passing it to the neural network. So that's going to be my these are going to be my next steps for for optimizing the model and training it on on a much larger data set. Finally, I would really want to thank you to Professor Zoran and all the TAs. They have been really helpful in during the course itself, and we have bugged them a lot for all the questions. So I think they really a big shout out to all the TAs and Professor Zoran. Thank you so much.